Hello friends, once again welcome back to Triple tutorial channel. Here in this video we will see a comparison between slip ring and squirrel cage induction motors. Already we have discussed about the construction and working of three-phase induction motors. We know that based on the construction of a rotor, these three-phase induction motors can be two types, squirrel cage and slip ring induction motors. Already we have discussed these points. So based on the construction of squirrel cage induction motor, it consists of a rotor having gauge type rotor. Okay. And the construction of squirrel cage induction motor is very simple when compared with the construction of slip ring induction motor. And the rotor consists of laminated copper or aluminum conductor and which are short circuited at the end by end rings or short circuited rings. Since the rotor of squirrel cage induction motors are permanently short circuited by the end rings or by the short circuited rings, it is not possible to add any external resistance to the rotor in order to improve the speed or in order to start the motor. It is not possible to provide the external resistance to the rotor because they are permanently short circuited. And remember that we know that the aluminum conductors are or copper conductors are short circuited by the end rings and they are not exactly parallel with each other, but they are slightly skewed. Why? Due to this following advantages. First, the skewing of rotor bars or rotor conductors will reduces the humming and thereby provide proper running for the motor. And this will provide smooth torque curves for the different position of rotor and it will reduces magnetic locking. So what will happen if magnetic locking occurs? Then it is clear that the rotor will rotate with a speed of synchronous speed. We know that the induction motors must always run below the synchronous speed. If magnetic locking occurs, it will just act like synchronous motors. So that magnetic locking can avoid by providing skewing on the rotor bars and it will increases the rotor resistance. These are the major 4 points or major 4 advantages for the skewing provided in the rotor bars. Okay. So now let us see construction of slip ring induction motor. We know that the motor employs wound rotor and in addition to the slip ring squirrel cage induction motor, the rotor portion consists of slip ring and brushes. Slip rings are provided here to add external resistance to the motor to improve the torque, starting torque, so that we can add external resistance to the rotor in the case of slip ring induction motor. To add this external resistance, we provide slip rings and brushes to the shaft. Okay, this is the major difference between slip ring and squirrel cage induction motor based on the construction. Okay. So here we will see the detailed comparison between slip ring and squirrel cage induction motors. Okay. First point is about the construction. We know that squirrel cage induction motor is very simple in construction because the rotor bars are permanently short circuited. Hence, we do not need slip rings or brushes to add external resistance. So complication is very less for the construction of squirrel cage induction motor, so that the construction is very simple for squirrel cage induction motor and the construction is complicated for slip ring induction motor due to the presence of slip rings, brushes, and external resistances. Okay. So due to this additional presence, the cost, second point is about cost. Cost is more costlier. For slip ring induction motor, it is very costlier, but for squirrel cage is cheaper. And the construction of rotor. For slip ring induction motor, it consists of laminated cores with parallel slots, and each slots consist of one bar. Okay. And squirrel cage induction motor, the slots are not parallel, but they are slightly skewed. Fourth point is about the starting torque. For squirrel cage induction motor, starting torque is very less, so that slip ring induction motors can be used. There we need high starting torque. So starting torque is higher for slip ring induction motor. And the fifth point is presence of brushes. Brushes are present in slip ring induction motor, but they are absent in squirrel cage induction motors. Sixth point is about the maintenance. Due to the presence of this external slip rings, brushes, and we can add external resistance to the rotor, so that frequent maintenance is needed for slip ring induction motor, and the maintenance is very less for squirrel cage induction motor. Copper losses are also very more for slip ring induction motor, and which are very less for squirrel cage induction motor. The next point is very important. Speed control. Speed control is possible for slip ring induction motor, but which is not possible for squirrel cage, because the rotor circuits are permanently short circuited. That is the main reason. Okay, now we can add the next point. We can add external resistance to the slip ring induction motor, but we cannot add external resistance to the squirrel cage induction motor. Next point is about the running torque. Running torque is less for slip ring induction motor, and which will be higher for squirrel cage induction motor. We have discussed that the starting torque is higher for slip ring induction motor, and which will be very less for squirrel cage induction motor. So where we need higher starting torque, there we can use slip ring induction motor. Where we need higher running torque, there we can use squirrel cage induction motor. Okay, and power factor is less for slip ring induction motor, which will be higher for squirrel cage induction motor. And the efficiency is less for slip ring induction motor, which will be more for squirrel cage induction motor. So based on this comparison, we can discuss about the uses of these three-phase induction motors. Mainly, slip ring induction motors are used for hoisters, cranes, or elevators, etc. That means where we need higher starting torque, there we can use slip ring induction motors. And squirrel cage induction motors are commonly used in lathe machines, blowers, fans, etc. So these are the major comparison for about the three-phase induction motors. Okay, thank you.